Yo, 2019 A2 Unit 4 Mechanics section, question 8, the differential equations question. I'm not going to fib, this first bit is not easy for 2 marks. This was a bit of a stinker. Let me go through it for you. Okay, so we have a box of mass projected along a horizontal surface, thank God there's no angle. Initial velocity, right? So think, initial velocity U, mass M2. The box experiences a variable resistive force. Now, resistive force implies it's negative, it's slowing it down, that's important. Force, mass, I'm thinking acceleration might come into this somewhere. And that resistive force is in terms of the velocity 0.4 v squared. And that v is the velocity at time t seconds, right? Show that v satisfies this equation. And this is quite tricky, okay? So let's have a look. What we know. So F equals ma. We're going to use a bit of N2. They've told us the force. They've told us it's resistive, so it's minus 0.4 v squared. That equals mass times acceleration. The mass is 2. So minus 0.4 v squared equals 2a. Take the 2 over, and you can get acceleration is 0.2 v squared, okay? Now, of course, acceleration is dv by dt. It is the rate of change of velocity. So you could go around the houses here, right, and use a suvat, but there's no need. You can just swap the a for a dv by dt, because it's the rate of change of velocity, equals minus 0.2 v squared. It's starting to look like what they've given us. If I multiply everything by 5, the 5 will come in front of the dv by dt. The 0.2 will turn into 1, bring it over, and the minus turns into a plus, and I end up with what I asked, 5 dv by dt plus v squared equals 0. Right, so that's a bit cheeky, a bit tricky, but doable. So on to the next bit then. Find an expression for v in terms of t. This is your separate the variables and integrate, work out the constant of integration, right? You've probably done this many times in class, so let's go through it. So I'll just move the paper up. Right, so there's the differential equation. And of course, when we've done these in class, you'll need something over here on the right, so I can bring the dt over and I can integrate with respect to t on the left and with respect to v on the right, okay? Now at the moment there's a 0 there. So let's get something over there. Let's just take that over. It becomes minus v squared. But of course I want all the v's now on the left, right? So what I'm going to do, I'm going to divide both sides by minus v squared. So if I divide this side by minus v squared, there it is. If I divide this side by minus v squared, it turns into 1. So that was just a bit of nerd skills to know what to do there. Now take the dt over, separate the variables and integrate. So take the dt over, chuck 2 integral signs in what's left, right? The right hand side is easy. The integral of 1 with respect to t is just t plus a constant of integration. Let's have a look at the left hand side. I've got to integrate minus 5 over v squared with respect to v. So bring this upstairs to make it look easier, or that's what I would do. So it's minus 5v to the minus 2. Now integrate it, raise the power by 1, becomes minus 1. Divide by that new power. The minus divided by the minus 1 just disappears out as a plus. Okay. So all I'm left with on the left is 5v to the minus 1. And on the right, I've got that t plus the constant of integration. I can bring that back downstairs now and get rid of the indice. 5 over v equals t plus c. Right, we're nearly there. They tell us in the question that the initial velocity is 0. Sorry, the initial velocity is 5. So when t is 0, v equals 5. So if I swap that for 5, 5 divided by 5 is 1. T is 0, that gives me c equals 1. So I can tidy this up now. So 5 over v equals t plus 1. They ask for an expression for v in terms of t. So they want v on the left equals something to do with t on the right. Okay, so just take it all over and tidy up. Take the v over, put that in brackets, and then you can bring the t plus 1 over and underneath to get the final answer of v equals 5 over t plus 1. I really enjoyed that question. I thought it was doable. There's no logs or anything involved in it, so I hope you agree that's doable. The last one, briefly explain why this model is not particularly realistic, right? Don't forget, it's a model of a box being slid along a horizontal surface. Well, you've got to be pretty nerdy to spot this, but this is a reciprocal function. Okay, something over t. Think of the graph of y equals 1 over x. If you could picture what that looks like, it never actually touches the axis, the reciprocal function, and this formula is one of them, and it implies a reciprocal type graph indicating the velocity would never reach 0, i.e. the box would never stop. And of course that isn't realistic, because at some point it would have to stop due to friction. Right? There we go. Another good question. See you at the next one.